Okay, our next little bit in section 2 of the heat and temperature unit, grade 7 science, is heat transfer. And we're actually going to look at 3 different ways in which heat will transfer. And what I mean by transfer is that it's moving from one point to another. Okay, so it's moving from one spot to another. As you know, heat will always move from where it's warmer, where there's more heat, to where there's less heat, to where it's cooler. Okay, so those 3 ways are conduction, convection, and radiation. And by a long shot, radiation is what I know the least about, so I'll only give you what I can do. Okay, so first one, conduction. Okay, conduction is the transfer of heat. Okay, this is the main part that you need to know. The transfer of heat between substances that are in contact with each other. Okay, so a good example is what we've got here. You've got a hot cup of hot chocolate, and you put the spoon in. Obviously, the hot chocolate and the spoon are touching. So the heat from the hot chocolate is going to transfer into the spoon because they're touching. Okay, and so that's how the heat moves. And you know, cooking implements and all that kind of stuff, there's all sorts of conduction going on there. The heat goes from the burner into the pan. It can travel up the handle possibly as well, right? Okay, so that's an example of conduction. The kicker here is the 2 objects are in contact with each other. And I want you to look at the very last part where it says heat energy, the heat energy continues to transfer from particle to particle. Okay, so it actually, one particle will have a certain amount of heat, and as it's bumping into or is in contact with the other particle, proximity-wise, then that heat energy can transfer from one particle to another. Okay, so a couple of things to go along with that. When we're dealing with conduction, and we can look at some various circumstances here, but sometimes we want materials that conduct heat. That means allows heat to go through them, like a frying pan, right? But a lot of the times, probably most of the time, we want materials called insulators that do not allow the easy transfer of heat. That means it stops the heat from moving, okay, from point A to point B. Okay. And some insulators, some good examples of insulators are plastic, wood, air is a good one, actually, styrofoam, actual insulation, which we'll talk about later in the unit as well. Okay. And if you think about in the kitchen, some of the materials, especially around the stove, you think about what are those made of, right? Why don't they burn? When you pick up, take something out of the oven, right? There's various types of oven mitts or materials that you can use to move hot metal, right? That's all heated up in the kitchen without burning yourself. Okay, so those materials are called insulators, and like I mentioned, materials that allow easy transfer of heat are called conductors. Okay, so that's our first type of heat transfer. This will happen in both solids and in liquids. Okay. All right. Next example is convection. Okay. Convection involves, it's kind of a long one, but transfer of heat in liquids or gases. First of all, it's only going to happen in liquid and gas. So transfer of heat when liquid or gas particles move from one area to another. Okay, that's not all of it though. Okay, when they do this, that material travels in circular patterns called convection currents. Okay, so that's kind of a big one that you need to remember. So if you look at this, awesome diagram I made. Okay, we got some red. So here's your hot plate. So there's the heat, orange heat, right? What happens here is that the particles at the bottom, down in here, we'll just say this is water, those particles, they start to heat up. Right? Now, when materials heat up, what happens to their particles? Okay, so you should be thinking about 3 things right now: space, movement, and attraction. Okay, so the one I want to focus on here, and the only one I'll really talk about, is the amount of space between the particles. So when that material heats up, the space between the particles gets bigger, right? Those particles spread out. And this, right at this area, because it's so warm, they become less dense. Less dense means the particles are spread. So less dense than the rest of the water inside of this container. So what happens is the less dense material goes up. Right? Now, as it does that, as it goes up, it loses heat, and it's away from the heat source. So now those particles move closer together because it's cooling off. So the particles move closer together. And up here, then they become more dense, right? Where does the more dense material go? That's right, it's going to fall back down. And then it's going to get heated up again, become less dense, and rise. Lose its heat, become more dense, and go back down. Those are called convection currents. Okay, I want to show you a couple. Let's start with the lava lamp. And this is the URL. So this is not my video. So I'm not taking credit for it at all. So whoever this person is, I just want to show you the lava lamp. So in a lava lamp, down here, same as the pot, right? Down here is where the heat source is. So it's heating up this wax. There's a blob of wax that's heated up. And it gets heated up to the point where, again, the particles are spreading out, and that wax becomes less dense than the water it's in. So when it becomes less dense, it goes up to the top. Now, when all that wax is up there, it's away from the heat source, right? So it loses its heat out the sides. Okay, particles get closer together. It becomes more dense, and as they become more dense, look out. Okay, as it becomes more dense, like this blob right here, it's going to drop down to the bottom, and then it's going to get heated up again. Okay, so same process. I'm going to show you another one, and this is a video done by the BBC. It's a documentary, Earth, the Power of the Planet. So again, I'm not taking credit for this whatsoever. There is the URL for this video, but I want to show you, we don't need the commentary, but I want to show you what's happening. This is actually inside the Earth's, inside the Earth. Okay, so you know the Earth has layers. We got the crust on top here, and the crust is not just one big chunk of land. It's a whole bunch of plates, right? And those plates move. That's a lot of rock moving, right? This material underneath in the mantle is moving those crustal plates, those tectonic plates. And they're doing it by convection currents. So let's watch this a little bit. So as you know, inside the core of the Earth is where it's hottest. So just like that hot plate, in here is where the material is going to be heated. The molten rock is going to be heated up. It's going to become less dense. And as it becomes less dense, it rises. Okay, it's going to come up here, lose its heat, and become more dense, and then go back down. Right? Over here, it's doing it in the other direction. Okay? And as such, that's what causes the plates to be moving. And depending on which way these currents are going, it will cause the plates to move a certain way as well. Actually, let me just erase that. Okay, so convection currents are all over the place. It's in your oven. There's convection currents there. Some rooms in a home or in a building are heated with convection currents as well. Okay, so there you go. There's that one. So we got conduction, convection current, convection, and the last one is radiation. So radiation is different from the other two because it does not rely on the movement of particles to transfer heat. I'll underline that too. Okay, it does not rely on particles. So the heat doesn't go from particle to particle. There's no convection currents involved here, anything like that. Instead, heat is transferred by invisible infrared waves. Okay, and they can travel short distances or really great distances, right? The sun being obviously a great supplier of this type of thermal energy. Okay. Energy transfer in this way is called radiant energy. Um, and the last little bit here, this energy is, and this is kind of elementary stuff, I guess, but it's absorbed by dark and dull objects. Okay, we're talking colors and surfaces, uh, and also is reflected by shiny and light colored objects. And you can think of some scenarios where that's the case. Probably the biggest one for this, the shiny, is people that go skiing. Like it's cold out, right? But they can get sunburns because the light is hitting all that snow, and it's all shiny, it's all light colored, so it's bouncing off the snow, hitting them right in the face, and that's how we get people getting burned up. Okay, okay, that should do for conduction, convection, and radiation.